Okay. So, hi everyone, and welcome to week 2 of Fair February at the Data Science Initiative. This week, as you know, is about social justice and health. So we're going to kick off this week with two brilliant talks, both with a focus on India. The first one is going to be from Aashish Gupta, who is a demographer and currently a postdoctoral fellow at the Harvard Center for Population and Development Studies. Aashish will be talking about social disadvantage and life expectancy in India. And then we have Aditi Bhaumik, who is the director of the Development Data Lab based in India. And so I'll give the floor to you, Aashish, and then to Aditi at 2:30.
Thanks. Thanks so much, Aditi. Thanks for inviting me to present this work on social disadvantage and life expectancy in India. This is collaborative work with co-authors. Some of one is a dissertation chapter, and then one paper is with Nikhil Sudarshanan, and another with Payal and Sangeeta. Hopefully, you'll see that this is not too much, and actually these papers fit together. So just to motivate this talk, so Indian society is digitally stratified along multiple axes: caste, religion, class, gender. Except for gender, we don't have life expectancy disparity estimates. So if you think about life expectancy, it's a central for good reason. It's a central component for the Human Development Index. It's one of the central things we care about when we care about human development. Indeed, to experience any development, you have to be alive first, right? Within Indian society, there is widespread public and academic debate on human development outcome and on inequality within India. And so if we care about inequality, we would like to get a handle on this basic statistic of what are the mortality conditions different groups or different classes in India are exposed to. And then finally, I think as the pandemic has shown, there is improving empirical estimates of mortality is an urgent population science research priority. This is like a global scientific priority. We just need better estimates for the vast majority of countries where we don't have good data on mortality in particular, but population health in general. So if you think about GDP in India, you get GDP data every 3 months. It generates intense debate. And if you think about, okay, when were the last estimates of life expectancy in India, they were for the period 2014 to 18, not a quarter, but a 5-year period. And it's already been 3 years since then. So just to preview, I'm getting an echo.
We pause this one.
I feel there's another computer open, maybe. Is it at my end?
No, I think it's at our end. Yeah. Okay. Just give us a second. Yeah. Aashish, are you still getting the echo?
No, I don't think so. Okay, fine. Yeah. Thank you. Yeah. So I mean, please feel free to stop me if you have. I plan to speak for about 20 minutes, so there's enough time for questions. And also, if you want to stop me, please feel free to do that. So substantively, what I hope you will be convinced by is that these results show large and persistent life expectancy disparities in India by various measures of inequality by class or caste or social group. And then we also show that social group differences are not explained by differences in economic status. This is a perennial question across contexts, whether the US. So how much of inequality that we're saying, say, by race is because marginalized racial groups or marginalized social groups are also poorer. So how much of this can be explained by differences in economic status? We find that they're not explained by economic status. Methodologically, these sets of papers give some encouraging evidence on the value of empirical approaches to measure mortality. We don't need to constantly model mortality based on sort of heroic assumptions that we often do for low and middle income countries. We can do surveys, we can do large scale surveys and get real estimates. And then we develop some methods to estimate standard errors for mortality rates across the life course. This is sort of like a within demography or within data science contribution. So what is this creature period life expectancy? It is an important summary measure of mortality. It is not a projection. It's not that if period life expectancy today, say in India is 72 years, that people born today will live 72 years. It's a summary measure that if people, given the mortality conditions in India today, if people were subjected to this, then we would expect the average person to live at 72 years. Some people will die before, some people will die later. It's not a projection, is what is important uh, to remember. So the formal definition is the average number of years a hypothetical cohort will live if they experience the set of prevailing age-specific mortality rates. So we find mortality rates by age currently, and we think, okay, if a cohort were to experience these prevailing age-specific mortality rates throughout their life, how much on average would they live? This is much better than crude death rates, as for instance, those of you who know India would not be surprised to know that Bihar currently has lower crude death rates than Kerala, when Kerala has, I mean, we all know that Kerala has a better population. And the reason for this is mainly because Bihar just has a younger population. So the age composition of a population influences crude death rates, which is why demographers like to calculate period life expectancy. There are various approaches to calculate life tables. The standard approach in rich countries is counts of death. These come from civil registration and people. These come from censuses. So deaths go into the numerator, people go into the denominator. We calculate age-specific mortality rates. It's important to know that in many developing countries, civil registration and sometimes even censuses are not complete. So what we often do is survey estimates in a subset of population. The most famous among this is the demographic and health surveys, which provide estimates for child mortality often. But there are other surveys. In India, there is the sample registration system, which is sort of sites which are nationally representative, where demographic events are monitored. Demographers have also contributed to indirect approaches. I'm not going to go into details into these. If you're interested, I can answer, but think of them as modeling approaches based on extrapolations. So one way to calculate age-specific mortality rates empirically is to just ask people. So for instance, in the 4th round of the NFHS, this question was asked: did any usual member of your household die since January 2012? There were follow-up questions: sex, age, month, year of death. This question was also implemented in NFHS 1 and 2. So this is what I'm going to use to generate estimates of life expectancy by caste or class. There is some debate among demographers on whether to use this question. So for instance, older papers, Ken Hill, who's a famous demographer, wrote that in practice, the household death approach has given very disappointing results for both child and adult deaths. Similar comments by Ian Tiemus. And then there is an undercurrent of criticism of indirect papers. So Andrew Neumer gave a recent quote in Nature saying that demographers have been a part of the problem because we have had to put band-aids on this for 60 years. Extrapolations are basically what is calling band-aids. We've developed all sorts of techniques to estimate demographic rates in the absence of hard data. So we're going to revisit this in this talk. So how do we estimate deaths in person years? So for ages above 5, dead people come from this question on recent deaths and the household deaths. We create lifelines. So imagine that if a family member reported that you died, so in the beginning of the observation window, you were alive, and then we will measure you until your date of death, which is also in the survey. For alive members, these people we start at the beginning of the observation window and follow them until the interview date. For children, we use what is called the birth history module. This is much more standard within demography. In this approach, mothers are asked about all the children they've ever had and the survival status of their children. This estimating mortality rates from this approach is much more standard, and we use a very standard approach within demography to do mortality rates before 5. So bottom line is we obtain age-specific mortality rates across the life course. These are additional methodological details. We use national survey weights, we bootstrap standard errors. This is just, I'm going to skip this. If people are interested, I can answer in detail later. So this is what is this approach reliable? Okay, does it work? Are the questions that we're using, does it generate reliable age-specific mortality rates? These are standard. This is what age-specific mortality rates look like. They're high in childhood, then they decline in middle ages, and then there's rise with older ages. And so what in these graphs, we have in blue rates that we estimated from the NFHS. And then these are sort of India's national life tables. This is from the sample registration system. This is what the WHO uses to think about, okay, what is life expectancy in India? This is based on a large nationally representative survey. What you see is basically that they're very similar. There are minor differences. For instance, the NFHS one has greater age misreporting. It fluctuates more. The typical concern here in estimating mortality using survey approaches is you would not find enough mortality. So your mortality rates would be underestimated than what they are. In fact, here, if you see, for instance, from the SRS, we have about 60.9 or 62.3 years, and NFHS is about 6, right in the middle. For the more recent period, we are basically very similar a life expectancy at birth. The other thing to note is that these rates in red from the SRS, they also need confidence intervals. The SRS is also clustered sample survey, but unfortunately, the data from the sample registration system is not available in the public domain, and we cannot estimate correct standard errors and confidence intervals for the SRS. Okay, so yeah.
There was a question from Aditi.
Go on.
Quick clarification question, Aashish. So you mentioned that for kids who are less than 5 years old, you have age-specific mortality. You have age-specific mortality because you have a record of if you passed away before age 5. Yes. But then for, obviously you don't observe at what age the kid passes away because you don't know what happens to the child after the survey. So then do you assume that the mortality at age 5 stays constant for the rest of the individual's life, or does that child just doesn't show up in the other bins?
Okay, sorry, I should clarify. So for ages, so there is a birth history module for which we have age-specific mortality rates before age 5, right? So between 0 to, so what we need for life tables is 0 to 1 and 1 to 4. We actually do observe the exact age at which a child dies in the NFHS, right? So this is what 0 to 1 and 1 to 4 rates we get. And then for ages above 5, we use this household, we use this question on recent household deaths. So again, the denominator is person years. So think about this, that if you were alive at the beginning of the survey or beginning of the observation in 2012, and then you were measured, say, in 2015, January, so you contribute 3 person years, right? And then, and so that and then say you would contribute 3 person years, let's say you were 10 years age. So you contribute 3 person years between the ages 10 and 13. And so you add all these person years and then you add all the deaths in those ages. That's how you get age-specific mortality rates.
Gotcha, makes sense. Thank you.
So I mean, we don't care about what happens to children after the date of the survey because we are exactly counting the exposure in terms of person years within the observation window.
Yeah, not making assumptions about what happens after. Because
no, we don't need to because we have the entire life course. Right,
Great.
Exactly.
Thank you.
Yeah, thanks. Okay, so yeah, so these first 2 rates are from the child history module, and then these rates are from the household death question. In fact, if you use the household death question to estimate child mortality here, it doesn't make any difference. But we were concerned that, okay, it's a standard approach. Let's use the birth history for child deaths. Yeah. So now that we have established this approach is reliable, we can directly get to our results. So this is life expectancy at age 0 for females and males, for at age 15 and at 60. Let's look at this portion first. So it shows life expectancy by social group. So scheduled tribes, these are indigenous peoples in India. They, in the more recent period, they had a life expectancy of 68 years. Then compare them to high caste individuals. These are privileged individuals within Indian society who have caste privilege. So they had a life expectancy of 72.2 years among women. Scheduled caste, very life expectancy similar or slightly higher than scheduled tribes. These are people who were considered untouchable. Both scheduled tribes and scheduled caste groups have some protections under the Indian constitutions. Muslims, who are India's largest religious minority and who have increasingly been marginalized with the rise of Hindu nationalism within Indian society, they have life expectancy that are sort of like average life expectancy, and the same for other backward classes. These are castes that were marginalized but were not considered untouchable. I want to flag one more thing, that if you look at an earlier period, say 1997 to 2000, sort of 20 years before, or more than 20 years before now, the Muslims had less of a disadvantage compared to high caste Hindus, but that disadvantage for both men, that disadvantage for both men and women has increased, which reflects, I think, the further marginalization of Muslims within Indian society. The reason why we have life expectancy at age 15 and age 60 is to tell you that, look, these life expectancy disparities are not just because of child mortality differences. Child mortality is what Indian state policies typically have focused on, but we can see differences across the life course. So marginalization is not just, so we need to care about marginalization among adults as well as among children. And so I want to also flag that these are not small differences. So these are greater than differences, say, between blacks and whites in the US. It's also in both relative as well as absolute sense. They're even greater relatively because life expectancy in the US is higher than it is in India. Then we have some estimates. So this is a dissertation chapter that I did with differences by household wealth. So within the demographic and health surveys, the households are asked about the assets that they own. And within demography as well as related social science, it's a standard approach to create an asset index. So this is what I do. And so we can estimate 8 specific mortality rates for each asset index. There are some advantages and disadvantages of any measure of social class. Asset indices have the disadvantage that they were measured at the time of the interview. There is a bidirectional relationship between wealth and mortality, and it's a relative measure. There are some advantages also, that this is available for all individuals. So occupation class is not available for women for all ages. So education is not available for all ages. And then it's easier to collect. So I'm going to rush through results. So this is life expectancy by octile. So this is basically how much you can parse the data from the previous NFHS and this NFHS. If you can parse it even more, you can have even finer categories, and so you still get similar results. So here, if you look at the previous period in NFHS 1 for women, we have really large differences, as many as 11 years in life expectancy at birth. These are sort of differences that are among the highest in the world. And then here in the more recent period, we have some reduction in inequalities as well as improvements in population health. This is the good story, right? Improvements in life expectancy at birth, but we still have large differences, as many as 9 years. Among men, differences are even larger, so as many as 12 years among men between the wealthiest and the poorest octiles. For the NFHS, you can break it down even further. For NFHS 4, you can break it down even further because it's just a much larger sample. So here, the poorest men have a poorest 5% of men in Indian society have life expectancy at birth of 58.6, and the richest men are 74. So about 14, more than 16 years difference, right? And so it's important to reflect on this, that, I mean, partly Amartya Sen, for instance, and John Reyes say that Indian society is part Sub-Saharan Africa, part California. You see Sub-Saharan African life expectancies, We don't see California levels here, but if you did the top 1% of Indian society, maybe you would see those kinds of disparities. This is just to say the same thing again, that it's not just childhood mortality, it's mortality across the life course. And then you would say that, caste and class intersect. So this is again, this data comes from 9 poor Indian states from the annual health survey. It doesn't come from the NFHS. The reason why we use the annual health survey, which was in 2010, is because it's just a much larger sample from these 9 Indian states. And so here you can see that we have life expectancy at birth among higher caste Hindus. So this is OBC plus high caste, and then this is the poorest marginalized SCs and STs, and you see differences across categories. Same patterns for men and women. I'm happy to talk more about Muslim patterns. It needs further investigation, but there are some preliminary explanations that we have also. This is by state. Again, across the 9 states, we see differences. And so I want to go to implications. I have other slides if people are interested in other results by rural-urban status and so on. What we find here are large, persistent, and consequential disparities from an Indian as well as global perspective. So if you think about global population health, and if you think about where you would want to improve, right? So Dalits have a population of over 200 million, Adivasis another 100 million. And then, so together, this is like the US population, right? And so if you think about some of the most marginalized social groups globally and whose health need to improve so that global population health can improve, we really should be caring much more about the health of these marginalized social groups, right? The other bit is that we sort of think about child mortality, and we should think about child mortality, but we see disparities across the life course, and we should be doing more to address adult health disparities. And finally, I think this is some encouraging evidence that, you can use large-scale surveys. These are not small surveys, any of them, but I think they give some evidence that we should not be using poor approaches to measure life expectancy for poor countries. There is capacity within low and middle income countries to improve our understanding of population health. Thank you.
Yeah, sorry. Thank you so much, Aashish. And I would just like to open the floor for questions to the audience, if there are any. Okay, I have a quick one. Yeah, thanks, Aashish, for this very eye-opening talk. One question I had was about the evidence on Muslim child mortality rates from Dean Spears. And it seems that Muslim children seem to be doing better, and the channels through which that works is better sanitation in Muslim neighborhood. So I'm wondering, do you have a sense of what are the factors that change that trend so drastically for adults?
Yeah, no, I think that's a great question. So as Arushi is pointing out, just to summarize, because of residential segregation, Muslims tend to live with Muslims, and Hindus tend to live with Hindus, and Muslims tend to use toilets more. So what happens is that they are less exposed to fecal germs, so disease environment is better. And past research has documented that despite social disadvantage, despite being poorer, Muslim children used to have a mortality advantage. We see some advantage, Arushi, in the childhood ages, and we see some advantage in the middle ages also, and we see a large disadvantage beyond 60. Now, why would you expect an advantage among Muslims beyond the childhood ages? There are some explanations for this. One is circumcision is associated with lesser rates of cervical cancers. Muslims are also Muslims are also less likely to drink alcohol because of religious practices, which also is an important cause of death within these younger ages. As you saw, mortality is lower, but among the prominent causes of death are liver cirrhosis, driven by alcohol use or accidental mortality linked to, again, alcohol use. So that's also lower. There is some past research on suicide mortality being lower also, again, partly driven by social factors or religious factors. We don't have evidence on this. And so I think if we have data on causes of death, we would be able to get a better handle on this. Yeah, thanks. I also want to point out that if you consider mental health and not physical health, Muslims in India, there is documented evidence that Muslims in India have really worse mental health than privileged social groups.
Okay, thank you. Any other questions? Okay. Then, yeah, thank you so much, Aashish, for this very policy relevant talk.